So here's our first example working with the tangent inverse form. Remember, tangent inverse has a square plus a square, and in this case I have constant squared plus variable expression squared. Since this is addition, if this problem were written as x plus 4 quantity squared plus 16, it is the same problem. It doesn't matter. Since this is addition, the order that you list these is irrelevant. The classic version is to list A first, and so that's what I will do, but you may list this with the variable first if you wish. So this is the tangent inverse form. And then the question is, what is A? What is playing the role of A? Well, what is getting squared? What's getting squared is 4. And then what is playing the role of U? U is what's getting squared, which is x plus 4. From that, we find the differential line. The derivative of x is 1. And that's not quite what we want. We want 5 dx. I mean, alternatively, what we could do is simply move this constant multiplier out front and be done with it. Or, alternately, we could say 5 du is equal to 5 dx, and that's how the translation works. And so now, when we translate into the new language, 16 is a squared, x plus 4 quantity squared is u squared, and then 5 dx is 5 du. And we have the tangent inverse form with the 5 multiplier out front. So it doesn't matter if you bring the 5 out and ignore it, or leave it in and account for it later. You still have to account for the constant multiplier. And so now this is the form. Here's the tangent inverse antiderivative form. And so this is 5, and then we need 1 over a tangent inverse of u over a. Do not try to put your final result. Have the form, write the form, and then substitute. You'll make a lot fewer errors if you do it this way. You'll also get credit for your work. So this is 5 times was a. A is now 4, so this is 1 over 4. Tangent inverse of u was x plus 4 over a was 4 plus constant, and we're out. So once you account for everything, this tangent, assuming you know the antiderivative forms, this is not really brutally challenging. There are a few things you need to watch out for, and that's what's going to be coming next here. So here's my second example with tangent inverse. We have the antiderivative of e to the x over 7 plus e to the 2x. And the key to this is e to the 2x occurs often, occurs over and over again. Remember that e to the 2x, using the basic rules of exponents, is e to the x quantity squared. So I'm actually going to rewrite that. I think it actually helps to see things a little better. This is e to the x quantity squared. Just the first time at least, you might want to go ahead and write that in. You don't need to. Eventually, you begin to see it this way in your mind's eye, even if you don't physically write it this way. And so now this is the tangent inverse form, because we have a constant squared plus variable expression squared in the denominator. And so let's see if we can make this work out. A is, now what's getting squared? You might think, well, 7 is not a perfect square. Well, sure it is. It's the square root of 7 squared. So even if this is not a perfect square, that's fine. You can still use the square root of 7. One requirement when we're doing this process is the value of a must be positive. And then we also have u. What value is getting squared? What's getting squared is e to the x, and then this makes it particularly easy because the differential line, the derivative of e to the x is e to the x times dx, and that is precisely what we're left over with. So we actually, by this differential line, we're already having an exact substitution. So substitute all the values. There are no constant multipliers to deal with. e to the x dx is simply du. And then 7 is radical 7 quantity squared, that's a squared, plus e to the x quantity squared is u squared. That is precisely the tangent inverse form. So write out the form. Don't try to fill these in on the fly. Write out the form, and then this is now 1 over square root 7. And you do not need to simplify that. Just leave it as 1 over radical 7. Tangent inverse of u is e to the x over square root of 7. You don't need to simplify that either. And the trick is done. So tangent inverse, it's a square plus a square, and it doesn't matter what order they're in. And there's a tangent inverse. Remember, the tangent inverse form has 1 over a, sine inverse does not. So those are a couple of examples of problems working with the tangent inverse form.